Hello guys, welcome back to my channel. Today we're going to configure a small network high availability. For this network we just have um, two switches. We have an access switch, okay, on which we're going to plug a one PC. We have one core switch, okay, and on the core switch we're going to configure the we're going to plug in the multi-layer switches, two multi-layer switches. Multi-layer switch 1 and 2, and then between the multi-layer switches we have we're going to configure port channel between port fastness 0, 23 and 24, and then we have one edge router that's connected to a DNS server, web server, okay. So nothing is configured yet. There's an interface here that was configured, but I'll have to change that IP from 172.16.2.1. I have to change it to .3 just to make the IP naming more user friendly. So basically for the IP subnets, I'm going to use 172.16.2, okay, on the core end, and then on the endpoint, the PCN is going to be 192.168.10.0, okay, /24. So, and then on the internet facing side, it's going to be 8.8.4.0. So I actually already configured the web server here. Let's check. Going to IP address 8.8.4.4. I gave the subnet mask. No gateway because it's an internet server, okay. And then we have designed it as the DNS server. Let's go into services and see. If we check DNS, it's DNS enabled, and we give an A record cisco.com and with an IP 8.8.4.4. HTTP and HTTPS also enabled. So let's just give an IP address to the edge router. That's the internet facing IP address on the edge router. Let's go in there. Let's call this one 8.8.4.5. Give the same subnet mask as on the web server because they're really connected. Okay, and then we give an IP address on the LAN facing side of the edge router. There's an IP address already there, but I said we're going to change it just so it matches, so it's more user friendly. It's going to be .3 here, and you're going to see why it's I want it to be more user friendly. So I close out of there, and then I go into the first multi-layer switch here. Enable, configure terminal. First thing we want to do is to give an IP address, give him the host name, sorry. Let me just pull this one by the side so I can see it better. I actually do have a cheat sheet here just to make it easier for me to see the steps. So the first thing on the first multi-layer switch is giving a host name. So the host name is going to be MS1, and then we're going to allow routing between the multi-layer switches and the edge router. Okay, so we gave it IP routing. Since it's a switch, you have to enable routing on the switch. So routing is enabled on that switch. Now we have to give an IP address to the port that's facing the edge router, okay, through the switch, to the core switch. So this port, the IP address is gigahertz 0/1, okay. It has to be the same IP here. If we do like this, you can see it's okay, yeah, 0/1. I tried to make it to be just symmetrical. So the port here you see here is the same port number, the port number you see on the multi-layer switch. So we come here, interface 0/1. Now this port is a switch port. We have to convert it to a routing port in order to give an IP address. So it's a node switch port. and also say no short. Then we'll give an IP address 172.172.16.2. Let's give it .1. Okay, and then the next thing we want to do here is to convert this fastnet 023, not fastnet, yeah, fastnet 023 to fastnet 024. We have to convert them to port channel. Okay, so we say interface range fastnet 0/23 to 24. Call it channel group 1, mode on. Okay, the same no short. And then exit from there. We'll just exit and go to the other switch. Let's go to the other one and do the same. Enable, configure terminal, give a host name, multi-layer switch 2. Then convert. We have to enable routing on that switch, so it's going to be IP routing. And then we give an IP address to gigahertz 0/2 interface 0/2, no switch port, no short, IP address 172.16.2.2. Okay, so and then next we have to convert the fastnet 023 and 24 to Ether channel, to port channel. Okay, so it's gonna be exit over there, interface range fastnet 0/23 to 24, channel group 1, mode on. Okay, so if I do exit out of there, and I do first of all I have to save. There's a show Ether channel summary. Okay, so we can see Ether channel has been formed between port 23 and port 24. Okay, so Ether channel has been formed between port 23 and 24, and now we have to configure that port, that Ether channel port, as a trunk port, as well as the fastnet 02 port from that's connecting to the access switch. We have to convert that one as trunk port as well. So let's go back into the configuration mode. Interface. Now we're going to call this Ether channel port as port channel 1. Okay, interface port channel 1, port channel. We'll just call it port 1. Okay, switch port, trunk, encapsulation. Okay, and then switch port mode trunk. Okay, do the same thing on fastnet 02, interface fastnet 0/2, switch port trunk, encapsulation the one cure, switch port mode trunk. We exit out of there and save. And we're going to do exactly the same thing on the multi-layer switch 1. Okay, let me just show run. just to double check everything we configured so far. All right, let's just go to multi-layer switch. We want to do exactly the same thing. Configure terminal. So now what we're doing now is we have to convert those the port channel to a trunk port and the fastener 01 to a trunk port as well. So let's convert interface fastener 0/1 switch port trunk encapsulation and here switch port mode trunk. Okay, and then exit interface no, this one, then interface port channel 1. Okay, so we don't have to call it interface range fastener 03 23 and 24 anymore because it's already bundled. Interface port channel 1. Okay, so we'll call it switch port trunk encapsulation dot switch port mode trunk. Okay, so that's done. Now we can check the trunk interfaces. Okay, let's do show interface trunk. Okay, okay, so we can see the trunk ports. So port channel 1 is a trunk port, and port fastener 01 is also a trunk port. You can see that right there. Okay, and it's allowing all VLANs. If you go on multi-layer switch 2, we're going to see the same thing, but just check there. Show interface trunk. Yeah, the same thing. So now this part is done. Let's configure the access switch. So the access switch, first we want to do on the access switch is to enable VLAN 10. Okay, because as we said, the IP address on the endpoint facing part of the multi-layer switch is going to be 192.168. I actually do have it here. So the IP address given here is going to be 192.168.10.0/24, and then on the core switch end of the LAN side is 172.16.2.0. Okay, so so let's configure this on the access switch. Okay, so configure terminal hostname. Let's call it access switch, and then we have to create a VLAN 10. Okay, exit out of there. The interface VLAN 10. Okay, we'll give him an IP. We'll give him. No, we don't have to give an IP address. We don't have to give an IP address. No, we don't have to give an IP address. Exit. Okay. So what we have to do right now, we're going to put this port 3. Okay, we're going to put this port 3 as an access port, and then we'll give it VLAN 10. Okay, so interface fastener 0/3 switch port mode access switch port access VLAN 10. Okay, so now anything plugged on this port fastener 3, we've given the IP address of the 192.168.10. anything, it should connect. Okay, it should be able to reach out to internet anywhere. So that's done. Now the only thing left on the access port on the access switch is to convert these two ports, fastener 01 and 02, to trunk ports. So let me exit out of here. The interface range fastener 0/1 to 2. switch up switch port mode trunk. Let me just see. Yep, switch port mode trunk, and just like that, the ports are converted to the trunk ports. So the next thing we want to do is to go into the multi-layer switch and make sure that we create the VLAN 10 and also give an IP address to interface VLAN 10, okay, for multi-layer switch 1 and 2. So let's go into multi-layer switch 1, configure terminal. We have to create the VLAN 10. Okay, VLAN 10, exit. Give an IP address. We're going to give for VLAN 10. We're going to give on multi-layer switch 1. We're going to give we'll give 192.168.10.11. So we give IP interface VLAN 10, IP address 10.10. Okay, let's call it 10.10 or 10.11. Okay, 255.255.0. We save it. We'll go to the second multi-layer switch. Configure terminal. Create a VLAN 10. Exit out of there. Say interface VLAN 10. IP address 192.168.10.22. I think that's what I got here. Okay, with a subnet mask of 255.255.255.0. Exit out of there, save it. So now the VLAN 10 is already configured on the multi-layer switches. Let's just double check to be sure. Let's start with this one. Let's see what the configuration we have so far. Say show run. Just to be sure everything is according to the plan. Port channel 1 is created. Okay. Okay. We'll see if interface VLAN 10 is created with an IP address. Okay, and we have the same thing here as well. Sure. Interface VLAN 10 created. Okay, with that IP address. Okay. Now, next phase of our work is going to be to create to configure HSRP between the two multi-layer switches. Okay, so the HSRP, you're going to create a virtual IP address. Okay, that way if this interface fails, okay, this PC should always be able to get to the internet using not a physical IP address but a virtual IP address. Okay, so we're going to create that with HSRP, and because we don't want to rely on physical interfaces, okay, being up or down, for us to have access to internet. So that's why we created this. So let's go first to the multi-layer switch 1. And so I have the cheat sheet here. Configure terminal, and then we're going to say interface VLAN 10. We're going to give an IP address. First we create the standby group. Let's call it standby group 10. Okay, to match the VLAN. So standby group 10 IP 192.168.10.100. We're going to give it an IP at 100. And standby group 1, group 10, sorry, preempt. And then we're also going to set a priority. Okay, so the priority of 1115 is for this interface, the fast Ethernet 01 interface of the multi-layer switch. So if the fast Ethernet 01 goes down, okay, then it means that this guy loses his priority and this guy should take over. Okay, that's why we set the priority. So we set we're going to set the priority of 115. Okay, that's a good one. Okay, let me. Okay, I'm gonna. I can't see what I'm typing. Something wrong here on my keyboard. Yeah, so we created the standby group, but we have to set a priority on the, okay, so say standby group 1, okay, standby group 10, we create a priority of 115, and the reason, as I said, is because if this interface fast Ethernet 01 fails, then multi-layer switch 2 is going to assume that this guy is no longer reachable, so it's going to take over. Okay, so we want to give him as active. We want to assign him active router, okay, for the HSRP group, and if that router is unreachable, then this multi-layer switch is the one going to take over. But in any case, they're going to be using a virtual IP address. Okay, the 192.168.10.100 is going to be the virtual IP address they're going to use. Okay, so so we created the priority, and I'm not going to set the tracking interface right now. We're going to come to that later. So let's exit out of there. We show run. So interface VLAN 10, we created the standby group with a given IP address, and then also set this preempt, and then priority we set. So now we have to do the same thing on the other on the multi-layer switch number 2. Configure terminal, interface VLAN 10, standby 10, IP 192.168.10.100. Okay, standby group 10 preempt. Okay, and that's it. We don't want to set the priority for multi-layer switch 2 because we just have 2 routers here. Okay, we just have 2 switches here. So whatever happens on gigahertz 02, okay, if it fails, I'm sorry, not the gigahertz, the LAN side, the PC facing side. That's if this fast Ethernet 02 fails, okay, then this guy should pick over. But if both of them fail, of course, that's a major issue because he's never going to be able to get to the internet. That's why we don't need to track this interface, because we assume that this one is always going to be active as long as this one maybe is fail or whatever. Okay, so both of them, if both of them fail at the same time, then of course there's no way we can get to internet. So now let's check, just double check to see if HSRP is working. We're going to do show standby. So on multi-layer switch 2, we see the group standby group is 10. Okay, we see an IP address that is set for this of the active router is 192.168.10.11. okay, and the default priority, okay, for multi-layer switch 2 is 100. Okay, so let's check on the other side, but before we do that, let's just do show standby brief, so we can kind of see a summary of this, and we see that this particular router multi-layer switch 2 is local. Okay, the standby is local, which means it's the standby. Now the active router is a 10.11. okay, right here. So Let's go to the multi-layer switch 1 and see what it has. Okay, show standby. So we see group 10 is a group for the HSRP, and then we give a virtual IP of .100. Then the standby router is this one, okay, multi-layer switch 2, and the configured priority is 115. Okay, so yeah, so everything is good. And if we do that command show standby brief, we're going to see just confirm what we already saw on the multi-layer switch 2. So that's done. So multi-layer switch, the multi-layer switches are all configured for HSRP, and we gave a virtual IP address here. Okay, so let's try to see if we can ping that virtual IP address from the PC. Okay, so let's go into the PC and give an IP address. I think we didn't give any IP there yet, so let's give an IP. Let's call it 192.168.10.50, and we give it the default gateway. Now is going to be the virtual IP address. Okay, 192.168.10.100. Okay, we don't have a DNS server. We do have a DNS server, but let me just put it right now because we're not going to need it. But let me right now 8.8.4.4. So exit out of there. No, actually we have to come back there and do a ping. Let's see if we can ping the HSRP virtual IP address. Ping 192.168.10.100. Okay, that's responding. So that's responding. That's good. Now, but if we want to ping, the edge router from this one, we're not going to be able to do that. Okay, let's try it. So the edge router is going to be the edge router one LAN facing interface IP address is going to be 16. It's going to be 172.16.2.3. okay, so we have .3 here, .1 here, and .2 here. So let's try to ping 172.16.2.3. Okay, fair enough, it's not responding. And the reason it's not responding is that this PC doesn't know how to get to that network, because with that information is not, there's no routing between the multi-layer switches and the edge router. So now we have to configure OSPF between the multi-layer switches and the edge router. Okay, we're going to start with this one. We're going to start with multi-layer switch 1. I do have the cheat sheet here. So we're going to start with multi-layer switch 1. Configure terminal. And say router OSPF1, process 1. And for network, we're going to configure, actually we're going to configure anything that's attached to, all networks that are attached to this multi-layer switch. Okay, so we want all this network attached to it to be advertised to the edge router. So we say network, any network, okay, with the subnet 255.255.255.255, an area SPF area 0. Okay, so I will set the passive interface for VLAN 10, but that command is not necessary. Let me just see if it works without that command. Okay, but I could still set it up. So let's just say passive interface than 10. Let's save that, and let's go to the second multi-layer switch and do the same thing. Configure terminal, router, OSPF, process 1, network, any network attached to it. OSPF area 0, passive interface VLAN 10. We save that, and we'll do the, now we have to configure routing on the edge router, okay, but we have to make sure we're advertising only the LAN network, okay, because we don't want our LAN networks to be found on the internet. Okay, internet should only be public IP addresses, and for now we have the 8.8.4.0, which is a public IP. All the other IPs on the LAN side should not be seen on the other side. So we're going to go to the edge router and advertise only the LAN facing network. So go in there, so say configure terminal. I didn't give a hostname edge router, and then we say router OSPF process 1. Now network, we have to actually give the network 172.16.2.0.255 area 0. Okay, go up to there and save. Now let's see if on the edge router we can see the routes coming from the one. Okay, we can actually see the routes being populated right now. You can see 192.168.10.11, okay, and .12 and the 22 are being populated. So if we do show IP route, you see now we can see all those networks that we could not that were not available on this router. Now those networks are there, but let's try to ping it. Let's try to test if there's connectivity from the PC at least to the LAN side of the edge router. Okay, let's try to ping it. If you come here and do the same ping that we just tested not too long ago. Okay, that ping works. Okay, now ping works, but our goal is to be able to reach the internet. Okay, we assume this is the internet here, so we want to be able to use this PC and get to the internet. So how do we do that? So basically we've configured OSPF, the multi-layer switches and the edge routers talking to each other on OSPF, and we can actually ping from the PC to the LAN facing side of the edge router, and but our goal is also to be able to ping all across to the DNS server, okay, to the web, to the internet. So the first thing we want to do is to enable this interface. I think we put an IP address, but we did not enable that interface. We did not. Just check in there. If we do show IP interface brief, you can see the internet facing IP is configured, but the interface is not enabled. So we'll go configure terminal interface 0/0 no shot, and then we save. Okay, now the interface is up. Okay, the interface is up, but even if I try to ping it, I still cannot ping it. I should not be able to ping. Let's see if I can ping it anyways. Let's see if I can ping it. Maybe I should, but let me check. 8.4.5. Okay. Okay, so unreachable, why? And by the way, who is giving that information is the multi-layer switch. Okay, so this is the multi-layer switch giving that information. So basically we cannot ping here, and we cannot ping by default also the web server. And the reason is because this is an outside interface. It's an internet IP address we're trying to ping, and for that to happen we have to basically allow that traffic on the edge router. So we're going to do some NATing on the edge router. So before doing the NATing, we have to configure a default route on the edge router. Okay, configure terminal, say IP route, say IP route to anywhere, any subnet. Okay, so out to IP route to any IP address with any subnet. Okay, on the internet. Looks like I gave a little bit an extra. Okay, that makes sense now. All right, so it's going to go out interface gigahertz 0/0. So if anybody tries to go to internet from any IP address, so if anybody tries to go to internet on any IP address, okay, using any IP subnet, okay, that traffic has to go out gigahertz 0/0. Okay, so enter. I was gonna see here impact performance. Okay, all right, so that's done. Now next thing we have to configure on the OSPF. Go router OSPF process 1. We have to configure default information originate. So basically this is going to be our router that directs all traffic, internet directed traffic to that port, okay, to the port 0/0. So after doing this, we'll go back in there, save it. Let's try to ping that internet facing IP address of the edge router. Let's see if it's ping. Now it's pingable. Okay, now that IP is pingable, but the web server, the DNS server, should not be pingable because the DNS server, as we said it doesn't have a gateway that faces, doesn't have a gateway. So let's try to ping the DNS server. Okay, the reason the DNS server is not responding, okay, the reason the DNS server is not responding is because it doesn't have a gateway that points it back to. It doesn't have a gateway IP that points it back to our edge router, and that makes sense because it's a web server. Okay, it's somewhere on the internet. It should not be having its gateway as our edge router. So that makes sense. That's perfectly correct. So we're going to fix that right now. With a NATing statement on the edge router. Okay, so on the edge router, configure terminal. Let's configure. Let's call it interface gigahertz 0/0. Let's call it IP NAT outside. We'll set up outside interface, and then interface fast gigahertz 0/1 IP NAT inside. Okay, now after that, now we're going to start configuring the NATing statement. The first thing we want to do is define what is the subnet on the inside that we want to be able to have traffic going out to the internet. So we want the 192.168.10.0 to be able to have internet access. Okay, we want our PC to be able to have access to the internet. So we want to create an access list for that. Access list. 10 permit 192.168.10.0 255. Okay, and now after creating that, what's the next thing? Let me check here. Okay, now we're going to apply that access list. Okay, going to have to apply that access list. IP not inside source list, the source list 10, source list 10. Interface gigahertz 0/0. Okay, so that's done. Nothing statement is done. Let's save it. And if we do a ping test right now, let's do a ping test from the PC. Let's try to ping the DNS server. Let's try to ping the DNS server. That's 8.8.4.4 responding. Okay, so the ping is responding, and not only it's responding, but we should be able to use this DNS server on the here, right? Okay. So to use the DNS server, we just have to open up the browser. Okay, now we're going to type www.cisco.com. Okay, perfect. So everything is working. So DNS is working. The NATing is working on the router. We still have full connectivity, and we didn't talk about spanning tree protocol here, but it wasn't necessary. But in the next video, you're going to see that we have to basically set our routes, spanning tree route. We're going to have to select. Okay, but for now we didn't need it for this video. So it's been a very long video, and hopefully I should be able to make the next one shorter. So basically this is it. So thanks very much for listening. Thanks very much for always coming back to my channel, and if you're new, please consider subscribing. Could you add some comments so I know how I'm doing? Okay, thanks, and talk to you next time.